for this problem, you've got this projectile, or whatever, this ball coming in into the reference frame of this, this other ball coming towards it. So what we need to do is pretend, take one of these balls and lock them down as the main reference frame. So if we lock down the second ball, this one right here, and make this the center of the universe, then that means, this speed, which I'll do in yellow, is actually 7 meters per second instead of 4. And what we need to do then is use the Galilean transformation. So the Galilean transformation says V1 final is equal to M1, I believe it is, minus M2 over M1 plus M2 times V1 initial. And then we got V2 final should be equal to 2M1 over M1 plus M2 times V2 initial. Let me double check. Nope, just kidding. That's not V2 initial. That's V1 initial. So they're both times V1 initial. So now we can use this transformation in our the secondary reference frame, and we can say V1 final is going to be equal to 100 grams minus, the second one is 200, yes, minus 200 grams over 300 grams, and then that's times the original velocity of 4 meters per second. And the second one, V2F, is going to be 2 times 100 grams over 300 grams. And that's going to be, oh, I'm sorry, just kidding. We want to use our new shiny reference frame, which says 7 meters per second. Okay, and then that's going to give us 2 new velocities. So that's going to be negative 1/3, so it's like negative 7 thirds meters per second, and then this is negative, oh sorry, just kidding, it's positive 14 thirds meters per second. Now, both of those two are in our secondary reference frame, so we have to go back to our original reference frame, and you do that just by subtracting 3, right? So you just say V1 final minus 3 meters per second is going to give us our, V1 final original reference frame, if you will. So that's going to be negative 7 thirds minus, what is that, 9 thirds, which makes us negative 16 thirds meters per second. And then the other one, V2 final minus 3 meters per second equals V2 final in the original frame. So that's going to be 14 thirds minus 9 thirds, which gives us 5 thirds meters per second. All right, so that means our first projectile, our first ball is moving backwards at 5 1/3 meters per second. Our second ball is moving forward at 5 thirds meters per second. And there you go. So the key here, key thing to notice is there's a couple of major steps that have to be taken. Number one, we must shift our reference frame from the original, like both things are moving, where the reference frame is kind of like the x-axis, the origin, if you will. Now we have to shift that to one of these into an inertial reference frame where one of the balls is not moving, and then do the calculations from there. We also need to use the Galilean transformations, and we need to use that with our shifted reference frame first, and then go back, shift our reference frame back to the original, and we're good.